pound key. Thank you. I would now like to introduce the Global IAM Community Board President, Michael Helder. You may now begin.
Thanks, Susie, and welcome everyone to the IAM Community Webcast for September 2014. Our topic today is Software-Defined Networking, or SDN for short, and we have Michael Chavanel to present on that. But before we go to that, just let me get started with sharing some of the news from the IAM Community Board. We're having ongoing discussions during our board meetings with CA about vision and strategy for the IAM products and how this is communicated to customers and partners. This is a recurring topic on our monthly board meetings since it is important to us that CA knows how customers and partners respond to the information that is shared by them. We're looking forward to CA World in November where we can continue this discussion in person with some of our key contacts at CA. But if you have any input for us for these discussions from your own personal experience, please don't hesitate to contact us. We can bring it into those meetings with CA. Our contact information can be found on the community website. And just as a reminder for those who want to attend CA World, the early bird discount will end at the end of this week. That's a $200 discount for registering. But as a community member, you will also have a $200 extra discount if you register through the community website. Then we're in the very early stages of looking into having a technical event next year for the IAM product group. We're aiming to have something similar to what used to be Dev Buddy or similar events. If you have any ideas about that or can already say that you're interested in something like that, that would be great feedback to us. You can give your ideas and input through the community website again. We have the blog post with this type of information where you can respond or you can contact one of the board members directly. And then as a follow-up on our community survey a few months ago on software-defined networking, that's our topic for today. And Michael Chavanel will go over what SDN is and what CA is doing around it, what you should expect of the technology. The Q&A will be at the end of the presentation. You can use your phone lines as mentioned before, or you can use the Q&A panel. And we might be able to answer some of the questions already during the presentation if you post them online. And with that, I would like to hand it over to Michael. Go ahead.
Thanks, Michael. And good day to everyone on the line. Yes, we're looking forward to talking about SDN. I've been involved in this for about the last couple of years, and we at CA see SDN really as a disruptive technology, and I'll be talking about that this day. So here's an outline of what we're hoping to cover, really to talk about what SDN is, kind of in the basic sense, as well as giving some historical perspective on how we got there. We're going to talk about some of our current use cases, and really the prime one is fully dynamic networks. And we'll spend some time talking about why this is so disruptive to an incumbent hardware vendors and to infrastructure management vendors like CA. And we'll be going over some of the opportunities and recommendations that we have made based on our investigations with SDN. So let's start by defining software-defined networking. So from Wikipedia, I'm copying directly here, SDN is an approach to computer networking that allows network administrators to manage network services through abstraction of lower-level functionality. And continuing, this is done by decoupling the system that makes decisions about where traffic is sent, that is the control plane, from the underlying systems that forward traffic to the selected destinations, that is the data plane. So we did that, right? And that's perfectly clear. No, not really. So what we're hoping to do this morning is really put some color in and really some emphasis on different parts of that. And the challenge in SDN is many vendors have their own definition. And I'll actually talk about when people say SDN, here's what they may mean. But let's go back to some of the keywords from this definition here. If we had to pick out a few keywords, it's really about managing through abstraction, and a key concept is decoupling the control plane from the data plane. So those are kind of high-level concepts, but at least it gives us some context to talk about how we've arrived at this position. But it's a key, certainly the key thing is that it's a change in network paradigm on the way that networks are provisioned, configured, managed, and deployed. And certainly the decoupling is one thing that permits that. So let's talk about some of the common conceptions and even misconceptions. Years ago when SDN was really growing, and it certainly is growing rapidly now, SDN was seen as OpenFlow, and it's really not the same thing. SDN is really the umbrella term used to describe this whole architecture and paradigm. There's no particular single standard that encompasses SDN. It's really a concept more than a particular standard. Conversely, OpenFlow is a standard, is a very specific data model, protocol, agent for building programmable networks, and it's not the only approach. So for folks who are closely aligned with the OpenFlow community, certainly that is a valid way to do SDNs. OpenFlow, it's an open standard developed by the Open Network Foundation, and it can be used to implement SDNs. But like I said, it's certainly not the only way. It's one way, and there are several alternatives to OpenFlow. Even though OpenFlow certainly remains a consistent and a very strong tool to develop SDN networks, it's not the only one. So what's the big deal about SDN? There's so much chatter. You can hardly pick up a trade journal, Network World or whatever, and you know, you'll find articles very frequently on SDN. And everybody's claiming participation. Everybody's claiming software-defined something, right? Software-defined networking, software-defined data centers, software-defined devices, software-defined routing. So really everybody is claiming this, and it's true to some extent. Everybody's participating in this new ecosystem to some extent. So, and the truth is software-defined networks are not totally new, as much as the interest and the deployment of them have increased rapidly in the last probably 12 to 18 months. They really are not brand new, and a number of approaches have existed historically. There have been proprietary CLI scripts that have been, in a sense, software-defined networking, where you could run a script to configure a network dynamically. So that stuff has existed for some period of time. It's only there's been even standard ways to do that through Chef and Puppet to configure network-based resources. There's been netconf, which is an IETF standard as well, to do some of the automated provisioning and configuration of network elements. There's been XML RPC approaches. There's been XMPP has been used for this as well, Extensible Messaging and Presence Protocol. OpenFlow, as mentioned, really is one of the options for developing and building out an SDN and software-defined networking. And even SNMP has been described as a software approach to configure networks. So what's different? Like we'll talk about what's different today. Let's roll the clock back a couple years, and if we had this this conversation, this webcast 2 years ago, I'd probably be talking about the four things on this. I'd probably be talking in the core part being SDN controllers and OpenFlow. And we probably talk about OpenStack and SDN applications. And that was really the core of the conversation a couple years ago. That's really was the state of the technology, fairly in its beginning stages. So let's fast forward a couple years to today and kind of see how that discussion has changed. The discussion has really been greatly augmented by a lot of side discussions. So now when you talk about SDN to people, you may not be talking only about that core puzzle piece. You may be talking, if you say SDN to people, they will hear NFV, Network Function Virtualization. And that's a key and a growing body of work that is a technology for deploying and making software-defined networks. It actually takes the functionality that's embedded in appliances, routers, switches, firewalls, load balancers, and virtualize that as virtual images running those networking functions. So, like I said, if you say SDN to some people, they will actually hear NFV. Next one, going around the chart here, Cisco is a major player in SDN, plays at several parts of the ecosystem, from low-level protocols and agents to controllers to northbound applications to hardware assets to policy-based things to all kinds of, so Cisco is a very, very strong player in the current marketplace, having assets really at all levels of the SDN ecosystem. So if you say SDN to some people, they're going to think of these Cisco technologies. Others, if you say SDN, they're going to think of typically orchestration and provisioning applications, how I provision a circuit from A to B. Oftentimes in the service provider environments, they will think in these kinds of terms. NetConf and Yang, as I mentioned, NetConf is actually an older technology. The IETF standard came out for this probably about 8 or 9 years ago. It's really having a resurgence with the new interest in SDN. And Yang is the modeling, the data model, and the language used for NetConf-based systems. And also, if you say SDN to some people, they're going to think of VMware and network operating systems like VMware, and there are many of them that provide network virtualization functions through a unified fabric that's offered by a particular vendor or even open source. And lastly, if you say SDN to some people, they'll quickly reflect on the number of standards groups that are doing active work in some aspect of SDN. Like I said, SDN itself is not the standard, but some aspect, whether it be in protocols, modeling, agents, APIs, all these groups from ITF, and then the Open Network Foundation. Open Daylight is the open source foundation, that's ODL. OMG, Object Management Group, looking to standardize interfaces and modeling. And then there's ETSI, that's doing a lot of work in standardizing representations for NFV. So the discussion really over the last year has become a lot more complicated, and it's multifaceted. So there are lots of puzzle pieces to the SDN system now. I wanted to reflect back to the Webcast users from a survey we did from the CA-IM community back in July of this year. What we had done is we surveyed the community to get an understanding of the maturity of their SDN deployments and activities. So we had about 18.5% were currently active in July of this year doing lab and prototyping efforts. Kind of bumping up, they had about 7.5% were doing active development on product or production releases. There were 22% that actually were doing pre-production trials, basically live trials with SDN technology in various areas of their network or operation. And lastly, there were 7.5% that actually had a production deployment live at the time of the survey. So sort of the takeaway from this is about 37% of those surveyed were active in either development or deployment of an SDN technology. And it's probably worth saying survey size was relatively small. It's about 29 people, but it does show kind of a distribution of activities from lab to prototype to active development to really live trials, live production deployment. So let's talk about some of the use cases of particular interest to infrastructure management. One of the prime ones that historically folks have looked at and we've looked at as well is data center networks, where workload mobility is the use case. There's large CSP networks, that's communication service provider networks, where MPLS is, they're using SDN to provision MPLS or mobile circuits in a real-time manner. Big data networks, there's some customers we have that are using SDN to provision dynamic big data feeds, and this is done in lots of data centers and worldwide networks. Typically, one customer we have is working in like the high energy particle physics environment where they have massive amounts of data that needs to be transported around the globe to various research sites. Corporate wireless networks is another key use case. And lastly, SDN controller management, a key part of this discussion, as the discussion was 2 years ago, is about SDN controllers, and that's a big part of the use case going forward. So NFV, in the puzzle slide from 2014, we identified NFV, again, Network Functions Virtualization, as one of the key and the hot aspects of SDN. And it really allows software-based firewalls, load balancing, routing, QoS, intrusion detection, WAN acceleration, any of these things and technologies that are typically appliance-based that live in routers or appliances on the network. We're looking to take that capability, virtualize it, put it on a hypervisor of some sort, and run those images as in place of having all the appliances on the network. And all these technologies, they may or may not be OpenFlow enabled. Again, OpenFlow is one way to have an SDN network, but all these NFV components may not be OpenFlow enabled. So here's an example from the first use case. So I'm showing here large data center where we have rows and rows of racks and racks of equipment. And the challenge in data center mobility is, so let's say they have a workload that's located in some section of the data center, and the workload is operating well, but guess what? It's the World Series, or it's the Super Bowl, it's the World Cup, it's the shopping season, and all of a sudden that workload has to migrate to another part of the data center where there are more resources. So that workload migrates to another part, and instead of occupying a few machines, the footprint of that workload is enormous now, because it's the Olympics or the World Cup, some major event that requires requires a huge amount of increase in resources. So the workload and basically the compute and the storage moves easily. The challenge in networks of the recent networks is they come with a lot of strings attached. So as you move the workload, it's going to come with some strings attached, like IPsec tunnels to back to certain customer sites, or it's going to come with GRE tunnels to back-end databases elsewhere in the data center. It's going to come with firewall configurations out to the internet. It's going to come with QoS policy and priority settings to ensure quality of service on network traffic. It's going to come with SSL configurations for authentication, have VLAN configurations within the application. And it's also going to come with ACLs, that's access control lists, for management to manage this new workload. So you can see one part of the workload moved very well. The compute and the storage mobility, that's a mature technology. Network mobility is definitely a less mature technology, and this is really where SDN comes in. So let's talk about why SDN is disruptive. As mentioned, networks and network mobility has been the limiting factor in data center virtualization. And in the same way as host virtualization was disruptive 10 and 12 years ago, network virtualization and SDN is going to be very disruptive. And like host virtualization, the initial players in SDN, they weren't the major incumbent hardware vendors. They were, for the most part, startups. And incumbents have really moved aggressively over the last 18 months to pick up assets. There's been mergers and acquisitions. There's been a great amount of effort in kind of major hardware vendors like Cisco and Juniper and HP and NEC and Fujitsu, and Arista. Large, basically everybody's getting involved in some aspect of SDN. So really the incumbent hardware vendors have really moved aggressively over the last 18 months. And the point of SDN is it's going to be a major way to change in the way that networks are designed, provisioned, and managed. So some of the hardware vendors, like I said, were not initially leading this technology. In fact, they were seen as lagging behind. And there were some reasons for that. They had lots of proprietary expertise. Each vendor had their own way to differentiate themselves. They had proprietary programming languages or CLIs. They had special features, capabilities, and again, the marketplace is about differentiation. So incumbent hardware vendors 2 and 3 years ago really operated on differentiation. And the challenge was that once you bought into a particular vendor's hardware family, a lot of the control for that network lived inside the box, and the control stayed inside the box through the vendor-specific algorithms, technologies, and intellectual property. The point of SDN, at least the early efforts, was to really wrestle network control from the box, and in some cases even from the vendors. That was some of the early promise of SDN, to be able to take and open up some of those things, like opening up the control plane to some, whether new routing, new switching algorithms, new policies, things like that. And there's challenges to infrastructure management vendors like CA. These networks now, as I showed in the data center case, are highly dynamic. A workload that used to exist in one segment of the data center moves and expands rapidly into another data center area, and all the strings attached have to move with it too. So all the circuits you were monitoring in the previous thing, they've all moved someplace else. They could have different IP addresses. They're hosted on different resources. So a lot of information changes very quickly. The paradigm in the network management space has been oftentimes customers would do a scheduled discovery, and then they would poll the network periodically, 1 and 5 minute intervals to make sure that the network is healthy and operable. But in SDN networks, there's too much information and it changes much too quickly to do the daily or nightly discovery and polling paradigm. So we're really seeing a challenge to the way networks are managed. So the amount and the scope of changes is enormous. It used to be, years ago, topology was determined by the way that cables were plugged into Ethernet ports. Like the physical topology was the layer 2 topology, and it was originally static. That's no longer true. Topology, at least the overlay topology in SDN networks, is not static at all. It's highly dynamic and can be changing quite frequently throughout the day, can be changing as workloads need to move around, things happen. So, and that's a major change to the way networks are provisioned and deployed. And our opinion, certainly my opinion, is SNMP may no longer be the right tool for tracking this level of changes. SNMP has traps and indications, but they're generally so low level, and there would be so many of them, that we're sort of looking for a new paradigm for network management that really addresses all the possibilities brought forth by SDN. So we've produced really a unified vision, which is SDN and legacy management coexisting, because we expect the SDN world is really the evolving deployments, as we saw kind of in that market share survey, where people are in different positions of their deployment maturity. But as we see in the drawing here, we've got legacy SNMP devices, and we'll continue to have those that are managed and provisioned and configured in the same way. So we have kind of the CA family of applications in the yellow box here. Service management, performance management, fault management, configuration management, application performance management, kind of the suite and portfolio of CA applications. And certainly in the performance management, we would have things like CA Performance Manager, we'd have NIMSoft, we'd have eHealth, fault management, we have Spectrum and NIMSoft, configuration management, and then we have APM. So we have all those that operate in today's networks. Along comes the disruptive technology introduced by SDN. So we have on the blue side of the diagram kind of the SDN, kind of the new world that's evolving. And let's start from the bottom of that side. We have SDN capable devices that now will respond to SDN type technologies and requests. The SDN controller is really the core of this new architecture, which is responsible for really providing a platform and a framework for the SDN applications that are above it. Going up to that next box, we have a family of SDN applications, and those can be things like load balancing, firewalls. We could have routing, switching, WAN acceleration. Any type of network function really can be embedded there, or the configuration can be embedded there. So the challenge here is to manage those two environments side by side for the foreseeable future. The way we do that is we're introducing a concept where we have an API between the controller and the portfolio of CA products and between the SDN applications and the portfolio of products. So that green box that was just introduced there is the capability for existing products to now participate in the SDN ecosystem. And as you see by the numbers on the lines here going through, an initial service request comes in at the top and gets decomposed by the applications down to the controller, and the controller pushes that configuration down to the SDN devices below. And then at some point, the SDN ecosystem needs to notify service management that a new circuit has been provisioned. That's line number 3 in this drawing. So it notifies that through this API. So now service management is kept up to date with the moment-by-moment real-time provisioning of applications, services, circuits, all those things in the network. And line 4 is where you see the portfolio of products begin to manage the controller as well as the resources, the SDN resources, as well as certainly managing the traditional legacy resources. And what we'll see during that process is as, let's say, performance management takes on, it's going to start monitoring the network and collecting data. And from that performance data, it's going to be able to provide near real-time feedback to the SDN ecosystem that says, yeah, we understand you've just provisioned this new circuit. We're monitoring the utilization on that interface. We find that interface to be exceeding thresholds, the utilization threshold set by the user. The applications have that indication, now can re-provision and intelligently rather redistribute bandwidth or provision those resources differently so that we really have closed loop control. So the point of this, and really the core of this vision, is we have integration of both physical and virtual components. We have an integration and coexistence of SDN and legacy configured devices, and really the last piece being closed loop control, really allowing networks to be stable throughout this entire process. So we've done some early prototyping. This is probably from a year ago. I selected a popular SDN controller, and there's several of them. It had a REST API, and we wanted to show some of the data in NIMSoft, and we wanted to actually integrate that data with Spectrum and show events and alarms in Spectrum. Those are all CA products. So the components of this integration, we produced, we got some OpenFlow network elements. We use an SDN controller. Last year we used the Floodlight, which was a very popular SDN open source controller. We used the REST API of that controller and developed a NIMSoft probe that was communicating as a REST client to the Floodlight controller. And through that, we developed a probe, and we're able to manage the controller and some of the aspects and key performance metrics of that controller. So here's what it looked like. At the bottom left, you'll see some simple SDN-enabled switches, and above it, you'll see the Floodlight SDN controller. Again, this is a freely available open source controller that is used for SDN and OpenFlow. Part of the work that we've done is develop a probe that speaks to SDN's, the REST API in the Floodlight SDN controller. On the left side, on the right side, that probe feeds information back to the NIMSoft infrastructure management server. And that server sends informational traps to Spectrum through Spectra server, and that information is stored in the Spectrum database through models and then presented through the user interface so that the user actually receives real-time events and alarms on the health and status of the SDN controller. This is an example of one of the events that shows up. Basically, we're monitoring sys uptime of the SDN controller here. Pretty basic, but it does show that the prototype was able to use the REST API to collect performance metrics from the SDN controller. And this is what the UI looks like. This is Spectrum's one-click UI, and the highlighted node here was the prototype SDN manager. And underneath that, we had modeling for several different flavors of SDN controller. There are really a number of them out there. Even since this was done, Open Daylight has a controller called Hydrogen, which is really probably the most popular one now, which doesn't show up in this diagram. But this is really just for prototyping purposes. So I've had lots of people ask when they can get this. This particular capability is not on the roadmap today. We are certainly just demonstrating a proof of concept of Spectrum managing SDN controllers. So in summary, really the key takeaway is that SDN presents great opportunity and challenges to network operators. The opportunity is dynamic, flexible network, highly mobile topology and workloads, great things. The challenges are the fact that the management paradigm, the existing management paradigm, or say the incumbent management paradigm, is really not adequate to meet the real-time demands of new SDN networks. SDN itself is a rapidly maturing technology, as we saw by the community survey we had conducted a few months ago, that people are moving from lab prototypes to active design efforts to pre-production trials to production quality services. And the other part of our vision is we really expect there will be a long coexistence of both physical and virtual resources. As much as NFV, Network Function Virtualization, is really a hot topic in networks today, we understand that it's not going to happen overnight. There's going to be a very long coexistence period. We also expect a very long coexistence period between SNMP managed and configured devices and SDN managed and configured devices. Additionally, there will be multiple vendors as much as there are some incumbent leading vendors. There's always going to be market differentiation and diversification. And when we think as CA, we are in a good position. We're not a hardware vendor. We're well aligned with many hardware vendors to have partnerships and alliances. And lastly, we expect this will be a very long coexistence of multiple technologies. The entire ecosystem, whole data centers won't become SDN empowered overnight. I think it's going to be segment by segment or use case by use case where certain technologies will be adopted for SDN, where others will maintain the current practices for the foreseeable future. And it's really the use case itself that would dictate how aggressively that environment has to move to things like SDN and all of its associated technologies. And certainly, as mentioned, we really understand both the opportunities and the challenges that exist in this new world, this rapidly evolving and maturing SDN world. That's the end of our presentation. We'd be glad to take any questions either online or over the phone.
At this time, I would like to remind everyone, in order to ask a question, press star, then the number 1 on your telephone keypad. We'll pause for just a moment to compile the Q&A roster. Again, that's star 1. There are no questions on the phone.
Okay, and I don't see any questions in the Q&A panelist window. So Michael, do you want to take over at this point?
Yeah, sure. Thanks, Michael. I guess it was all either very interesting or people are still taking everything in. But thanks for the presentation and thanks for your time. Everyone else also, thanks for joining us. And we hope to see you again next month when we'll have eHealth on the schedule. Have a good day.
Thank you.
This concludes today's conference call. You may now disconnect.